Hi, grade 12s. Today we are doing area questions. Let's look at this example. It says, in the sketch alongside, PQ is parallel to AC. That's indicated. And PR is parallel to BC. Okay, and they also say BQ is to QC, 4 is to 3. So I'm going to fill that in. So this BQ over here is 4 and QC is 3. But because it's a ratio, let's add K. Let's add a letter. Just to show that it's not 4 centimeters. It's actually just a ratio. So the question is, determine the following. The area of triangle ABQ over the area of triangle ACQ. So this is ABQ and triangle ACQ. ACQ. So A to C and to Q and then back to A. So before I start, I want to show you something, grade 12. That's very important. So if you have a right angle triangle and you have to work out the area. Remember, area is a half base times height. Okay, so if this is the base, then this is, of course, the height because there is the perpendicular angle over there. So that's easy if you have a right angle triangle. If you have an acute triangle, you have to decide what your base is. So let's say, for example, you decide this is my base. If this is your base, your height must come from the highest point in the triangle, but you are standing here on the base. So if I'm standing here, this is the highest point. So my height would be drawn in here. I would draw in a perpendicular line, and that would be my height. So this whole thing is my base, and then that part is my height. Let's say you have an obtuse triangle like this. Then, let's say you want this to be your base. So this is your base. If that is your base, your height must come from the highest point, but you are standing here. This would be the highest point, but it must be a perpendicular line. It must come straight down. For this to come straight down, it's going to go outside of the triangle. So then this blue part would be the base, and that part would be the height. So for the left-hand side, so for ABQ, let's take ABQ out. If this is the base, then I will go to the highest point and bring a perpendicular line down. So for the area of ABQ, I'm going to say it's a half. Base is BQ times the height, which is a half times 4K times the height. Okay, and this must be over the area of the other triangle. AQC looks like this. It's an obtuse triangle, which means this is the base. So let's go. Half. The base is QC. So that's the base. The height will be, if this is the base and I'm standing here, I am standing here. The highest point is this point. But I must always come down. I can't go like that. I have to go straight down. So if I go straight down, I'm going down like this. Can you see here in our triangle? This is the highest point. And if you have to come down, isn't this the same height? So this H stays H. So then I say a half. QC is 3K. And H is H. So this and this will cancel. This and this will cancel. K and K will cancel. The ratio of the areas can be written as 4/3. And that's the answer. They want the area of BPQ. So let me highlight. BPQ. BPQ is over here. So they want the area of this one over the area of ABQ. So ABQ. We're busy with this question over here. Let's answer the question. Before I start, isn't there any ratios I can fill in? This is 4:3, so this is 4 and this is 3. I'm going to look for any prop theorem triangles. So I see the big one over here, this one. A, B, C. Do you see it? There. Those two lines are parallel. If this is 4:3, then this is also 4:3. Okay, let's fold that in. This is also 4 and this is also 3. I'm going to use another letter because that's a ratio. And that's prop theorem. I'm going to write that down. BQ over QC, that was given, is the same as BP over AP. And this is prop theorem. And the lines that are parallel is PQ is parallel to AC. Okay, you must just write that down. One thing I want you to notice, grade 12, is that the one triangle is inside the other. The red triangle is inside the orange triangle, which means they have a common angle, which is B. So B is in the small triangle and B is in the big one. When you have a common angle, or the one triangle is inside the other, you can also use the area rule. The area rule says area is equal to a half the one side times the other side times the sine of the included angle. Let's say if you have a triangle, this is A, this is small b, this is small c. So this is big A, big B, and C. The area would be a half times this, times that, times the sine of the included angle. That is the area rule, and it is on your formula page. I'm going to write the area of BPQ down. The area of BPQ is the red triangle. It's a half. I'm going to take out BPQ to show you. It's a half. I'm going to use the common angle. So it's a half this times the sine of that angle. So it's a half BQ times BP times the sine of angle B. I'm going to do the orange triangle. That is a half. And I'm just going to do the same thing. It's again BQ. But in the orange triangle, it's the whole of AB. It's this whole side. Okay? It's a half. This times the included angle. It's half BQ times AB times the sine of B. And let's cancel before we substitute. This and this can cancel. This and this is the same. This and this is also the same. BP is 4x. And AB is 7x. The answer is 4/7. Let's look at question C. It says, write down the ratio of the areas of triangle APR. I'm highlighting APR. APR is the small triangle here. And then I'm going to highlight ABC is the big triangle over there. Do you see grade 12? The blue one is inside the red one. So I'm going to use the sine rule. The blue one is inside the red one. That means they have a common angle. Their common angle is angle A. This one here. If that is the common angle, let me show you. If this is the common angle, I need this side and this side. But can you see I don't have this side? I don't have this side. So I'm going to go look if I can put in some ratios. Let's look for some prop theorem triangles. Do you see triangle ABC is a prop theorem triangle? Because this line is parallel to this. So if this is 3 and 4, then this is also 3 and 4. I'm going to put this in. This is 3 and 4. And I have to use a letter because I'm busy with ratios. I'll do P and P. I have to write down. I'm going to write AP over PB is the same as R over RC. And we said everything is 3 over 4. And the reason is prop theorem. These two lines are parallel. So PR is parallel to BC. Okay. Now I'm going to start with the area. Because the one triangle is inside the other, I'm going to use the sine rule because there's a common angle. I'm going to start with the blue triangle. That's APR. I'm going to say the area of APR is a half. Now remember, it's a half this times that. It's a half AP times AR. AP times AR times the sine of the included angle. We said the included angle is A. This is times sine A. Over. I'm going to do the same for the big triangle. For the big triangle, it's this whole side. This is A and this is B. And this is C and this is the included angle. It's AB times AC. So it's a half AB times AC times the sine of the included angle times the sine of the included angle. Let's see what can cancel. This and this, this and this. I have an AP and an AR. AP is 3x. I'm going to write that in times. AR is 3P over. The whole of AB is 7x. And this whole AC is 7P. And now let's simplify. This and this. This and this will cancel. 3 times 3 is 9. 7 times 7 is 49. And then you have the answer.